Good day, everyone. Hello, everyone. So, today we are going to have a presentation regarding understanding CATIA software. So, before we dive into the main presentation, I would first like to introduce my fellow members who are responsible for the presentation. So, our leader is Jan Abigail A. Guevarra, and the members are Precious JCG Padua, Lee Russell R. Cortes, John Christian N. Ganzon, Martell D. Manuilit, which is me, John Russell C. Maraña, and Russel Ian B. Remojo. On our way to understand the CATIA software, let us first have an introduction. So, what is CATIA? CATIA is not merely a word, but rather an acronym. So, the CATIA acronym stands for Computer Aided Three Dimensional Interactive Application. So simply, it is a software used to design and develop products, and this software is developed by Dassault Systems. So just like all the previously mentioned software in our subject, this one is also a CAD software. But what makes it different from the rest? What makes it remarkable, identifiable, or distinguishable? So CATIA is not your average software. It is a software integrating three types of engineering softwares into one program. So in one application rather, you already have computer aided design, computer aided manufacturing, and computer aided engineering. So knowing that it has various features and systems integrated into one program rather, it can safely be assumed that this application is very powerful and versatile. Knowing that it is powerful and versatile, it possibly has a wide range of applications spanning various industries. So, what are its applications? So, CATIA software is commonly used in industries such as aerospace, automotive, shipbuilding, industrial machinery, and consumer products. Now that we have discovered or know Katya's nature on the surface, its history and capabilities will be further discussed in the next slides.
Good day, everyone. So today I'll be talking and share a brief information about the CATIA, specifically its history and evolution. One of the leading software tools in the field of engineering and design. So, what is CATIA? So, CATIA stands for Computer Aided Three-Dimensional Interactive Application. Over the years, it has evolved into a powerful platform used for 3D modeling, simulation, and even manufacturing processes. What started as a specialized tool has now become essential across industries like aerospace, automotive, shipbuildings, and even consumer product designs. Its evolution had made it capable or handling very complex projects, allowing engineers and designers to visualize tests and refine their ideas before physical productions. So, thanks to them, thanks to its continuous development, CATIA remains one of the most reliable and widely used engineering tools in the world today. So, CATIA was first introduced in 1977 by a French software company by Dassault Systems. It was originally developed for Dassault Aviation, who needed a better way to design advanced aircraft components. At the same time, traditional 2D drafting methods weren't effective enough for complex shapes and systems involved in modern aircraft. So, CATIA was created to support 3D modeling and digital design, which gave engineers much more control and accuracy. Its success in aerospace led other industries to take notice, and soon companies in automotive and industrial design also began using it. And that's because of CATIA. From its beginning in the late 70s to now, CATIA has grown into a global standard for high-level design and engineering work. So that's all for the history of CATIA.
Hello everyone, I, Russel Maraña, and now we will proceed to CATIA interface. So, what is CATIA interface? CATIA interface is a modular, meaning it provides special environments. They called workbenches. Tailored to a specific task, the interface is designed to help you move smoothly in 3D modeling, 2D drafting, analysis, and simulation. And here are the main components. Number 1 is the menu bar. The menu bar provides access file operations, editing, viewing, tools, and other functions. Number 2 is toolbar. The toolbar contains icons, frequently used commands, such as sketching, part modeling, and assembly design. Number 3 is the specification tree or model tree. Displays the hierarchy of model, including the sketches, features, and assemblies. Number 4 is work area or the graphics window. The main space where 3D models and 2D sketches are created and modified. Number 4, work area or graphics window. The main space where 3D models and 2D sketches are created and modified. Number 5, command panel or dialog boxes. Appears when a specific feature or operation require additional input. Number 6 is status bar. Display messages, coordinates, and other information about the current model or operation. And the last one is workbench sector. It allows the users to switch between different workbenches. Each workbenches in CATIA provides a specialized set of tools for different tasks, such as Sketcher Workbench. The Sketcher Workbench is a 2D sketching tool for creating base profiles. Another one is Part Design Workbench. It is a 3D modeling and solid feature for creation. And another one is Assembly Design. Assembly Design Workbench is a tool for assembling multiple parts. And the last one is Generative Shape Design. It is an advanced surface modeling tools. And this is my and now we will proceed to the next reporter of the other.
Now I will highlight the key features of CATIA, a leading software used in engineering and design. CATIA provides powerful tools and making it essential for industries like aerospace and automotive. So the first key features of CATIA is advanced 3D modeling. So these features provides a powerful parametric and direct modeling environment. And also, engineers can create highly detailed 3D models of individuals, parts, and complex assemblies with exceptional accuracy. The software also supports both solid and surface modeling. So this results to enabling designers to develop intricate and geometries for various engineering applications. So the next CATIA's key features is surface modeling and design. One of the CATIA's strength lies in its surface modeling capabilities. It is also allows users to construct advanced freeform and Class A surfaces. So these tools are especially valuable for designing and components with complex aerodynamic or ergonomic requirements. such as vehicle exteriors and aircraft structures. So the third key features of CATIA is digital mockup or DMU. So these features naman includes tools for building complete digital mockups of products. So these features also enables engineers to visualize and evaluate assemblies at full scale. It also detects interference and perform kinematic simulations by reducing reliance on physical prototypes. The MU functionality significantly lowers development time and cost. Though the four key features is finite element analysis (FEA) and simulation. CATIA integrates computer aided engineering or CAE. These tools support finite element analysis so that users can perform structural, thermal, and dynamic simulations to assess how designs will behave under real-world conditions. So this integration streamlines the design validation process and improves product reliability.
Let's proceed to the next key features for CATIA. Um, Next key features is product lifecycle management or yung PLM integration. CATIA works with Innova to manage the entire product creation process and keeps everything organized. For example, a car company uses CATIA to design a new vehicle and Innova to track the entire process, from design, testing, and modification to final approval. Everyone involved designers, engineers, managers can see update and real-time collaboration. Next, sheet metal and weldment design. CATIA has tools to design things made of bent metal sheets or parts that are welded together. For example, an air conditioning company uses CATIA to design the metal casing of the unit and the welded metal frame that support it. Next is generative design and automation. CATIA can create a smart design automatically based on performance needs and rules set by engineers. For example, an aerospace engineer needs to design a lightweight bracket. CATIA used generative design to come up with the best shape that uses the less material but is still strong enough. It also fills out the standard holes and size automatically using built-in rules. And lastly, collaborative engineering. Collaborative engineering teams in different locations can work together on the same project in real time using the 3D experience platform. For example, an engineering team in Germany and a design team in India work on a new motorcycle part together. When one team makes a change, the other sees it instantly and can respond, like Google Docs for engineers.
Hello, so I will discuss the modules in CATIA. The first one is Part Design Module. This is where you build individual parts in 3D. Think of it like sculpting a solid model but with exact dimensions. You can tweak things easily because it's parametric and change one value and updates the design automatically. Next one is Assembly Design Module. Once you've made your parts, this module lets you snap them together like building a Lego set. You can see things if things fit right, check for clashes, and even see how parts move. Next one is Drafting Module. After you got your 3D model, you need 2D drawings to actually manufacture the thing. This module turns your 3D model into proper blueprints with dimensions. Next is Generative Shape Design or GSD module. This one is advanced. This is much more complex module. Think of it like making surface smooth or complex surfaces. Next one is Sheet Metal Design Module. This module is perfect if you're working with metal sheets. It helps you design parts that will be bent or punched out of a sheet metal like brackets or enclosures. Next is Kinematics and DMU module. Here's where you test how things move. You can simulate real life motion and even check if parts might bump into each other when they move. Next one is Finite Element Analysis or FEA module. Once everything looks good, there's no problem. This module helps you test the stress like heat, pressure, or force. Will it will there be a problem when you put the object under heat, pressure, or force? That's all. Thank you.
Good afternoon, everyone. I am Professor Padua, and I will be presenting applications of CATIA. So, CATIA is a widely used computer-aided design software developed by Dassault Systèmes, and in this presentation, I will present to you the different applications of CATIA in different industries. So, in first one, we have in aerospace engineering. So CATIA plays a crucial role in aerospace sector by enabling aircraft structural design, aerodynamic simulation, and composite material development. Leading aerospace companies like Airbus and Boeing use CATIA to create innovative aircraft designs that ensure high performance and safety. So here's a case study about Boeing 77 development. So, Boeing 77 was the first commercial aircraft developed by digital mock-ups instead of physical prototypes, thanks to CATIA. So, this approach, which is using CATIA to design this aircraft, reduce production costs by minimizing errors and material waste, improve design precision by allowing virtual testing before manufacturing, and lastly, enhance collaboration among engineers worldwide, streamlining the development process. So next is the automotive industry. So in automotive sector, CATIA helps design car bodies, simulate crash impact, and model engines and chassis components. Companies like BMW, Tesla, and Ford rely on CATIA for efficient vehicle design and safety improvement. Here is a case study of Tesla's Model S, which in Tesla used CATIA to optimize the aerodynamic and structural design of the Model S, making it one of the most energy-efficient electric cars. CATIA enabled rapid prototyping and testing of multiple design configurations, ensuring high performance and safety. The next industry wherein CATIA is used is in industrial machinery and equipment. CATIA is used to design heavy machinery and simulate automated manufacturing processes. This helps to improve efficiency, reduce production costs, and optimize design for durability and performance. The next field is in architecture and construction. Architects and civil engineers use CATIA for 3D modeling of buildings and infrastructures. It also integrates the Building Information Modeling, or BIM, allowing precise planning, visualization, and collaboration in large construction projects. So lastly is in medical and consumer products. In the medical field, CATIA is used to design prosthetics and medical devices, ensuring custom fits and improved functionality. Additionally, consumer electronics companies use CATIA for designing and household appliances and electronic gadgets, improving aesthetic and ergonomics. So everything wherein that's everything wherein CATIA is used in different applications in different industries. Thank you.
Okay, let me begin by discussing the advantages of CATIA. First, CATIA offers comprehensive capabilities integrating computer-aided design or CAD, computer-aided manufacturing or CAM, and computer-aided engineering or CAE in one platform. This integration helps streamline the entire product development process from designing to analysis and manufacturing. Second, CATIA delivers high precision and accuracy, making it ideal for industries where exact specifications are critical, such as automotive and aerospace. Third one, it supports advanced surface modeling, allowing engineers and designers to create complex freeform designs that will be challenging with other software. Okay, continuing with the advantages of CATIA, CATIA promotes efficient collaboration by using 3D Experience platform. It is the most advanced and the version of CATIA, which facilitates teamwork across departments or even global teams. It is also known for its scalability, meaning it can be used effectively for both small tasks and large scale industrial projects. And lastly, it includes strong simulation tools such as built in FEA or finite element analysis, kinematics, and motion analysis features. These tools help validate designs and improve performance without the need for separate software. Okay, despite the advantages of CATIA version 5 and CATIA 3D experience, still it has disadvantages. Firstly, the disadvantage of CATIA is it has high cost, making it less suitable for small businesses or startups with limited budgets. Secondly, the software has steep learning curve requiring significant training and time investment for us to master it. And third one, it has high system requirements, meaning it needs powerful hardware system to run efficiently. And lastly, limited file compatibility can pose challenges when working with files from other software, affecting interoperability in mixed software environments. So among these advantages and disadvantages, there are still more advantages rather than disadvantages of CATIA.
Now, to conclude, the CATIA software has a share of its own advantages and disadvantages. The CATIA software is very essential to engineers and designers across various fields. It is very powerful and versatile, making it a prominent choice for people working in product design or product development. Despite all of those wonders or great advantages, it has a major flaw, and that is it is very difficult to learn. It has a steep learning curve. But despite its seemingly overwhelming difficulty, once you put your effort into it and your time into it until you reach mastery, it will be worth the investment because once you have a full grip of it or full mastery of it, you will be able to create designs that are able to solve unsolvable problems. You will be able to create designs that are innovative or revolutionary, and perhaps it will be able to help you gain great fortune. So that would be all. Thank you.